Hey everyone, welcome to the Python One-Shot Masterclass, Part 1. I'm Simanta, and, well, I'm genuinely excited to be here with you today. This is actually my very first tutorial, so it's a big moment for me. We're going to try to get through this first part within about 1 to 2 hours, and my goal is to complete the entire one-shot series in just 3 to 4 parts. This isn't just theory, we're actually building something. By the end of this session, you'll go from zero to building your very first interactive application. If you're ready, please hit that subscribe button and share this with your friends. It really helps me out as I start this channel. Now, a quick shout out to the Codino app. It just launched on the Play Store this month, and it's a great way to practice these lessons through interactive visual tools on your phone. It makes learning Python way less stressful when you're on the go. Definitely check it out if you want to practice while you're away from your computer. But for today, we're going pro mode. We're using VS Code on the desktop because that's what developers use in the real world. I want you to get comfortable with the real tools from day one. So, okay, there we go. Let's get into the topic covered section.
All right, so here's our roadmap for today. We've got 5 main stops on this journey. First up is the setup. We're going to install Python 3, specifically version 3.12 or higher, and we're getting VS Code configured properly. Think of this as, preparing your garage before you start building a car. You need the right tools in place first. Then we move into variables and data types. This is the core, the foundation. We're talking about how computers remember things, basically how they store information. After that, it's math and logic. We're going to make Python do calculations for us. Addition, subtraction, but also some cooler stuff, like exponents and modulo operations. Fourth stop, text manipulation and fstrings. This is where we learn how to make our programs actually talk to us in a way that's readable and clean. And finally, the grand finale. We're making it all interactive. We're building a program that actually responds to user input. And at the very end, we're building a complete project called the Personal Bio Generator that pulls everything together. So yeah, stick around until the end. It's going to be worth it, I promise. Phase 1. Why Python? So, why Python? Like, why are we even here learning this language specifically? Well, first off, and this is a big one, Python has this really simple human-like syntax. I mean, when you read Python code, it almost looks like English. It's not full of weird symbols and semicolons everywhere like some other languages I could mention. It's just very clean. Second, Python is the #1 language for AI and machine learning. And I'm not just saying that to sound cool. Like, if you look at what's happening in tech right now in 2026, every major AI framework, TensorFlow, PyTorch, all of them, they're built on Python. So if you want to work in AI, data science, automation, Python is basically your entry ticket. And third, the community support is just massive. If you get stuck, there are millions of developers out there who've probably had the exact same problem. Stack Overflow, Reddit, Discord servers. So yeah, you're never really alone when you're learning Python. So, that's the why. Now let's actually get into the how and start setting up our environment.
Okay, so I'm right now on python.org/downloads/website. You see this download Python install manager text at the bottom of that says, or get the standalone installer for Python 3.14.2? Yeah, just click that. It will download the exe file, which is better and safer for installation. Then you have to just, accept it, stuff, which I'm not showing because I already installed it. But, make sure you check that box that says Add Python to Path. It's super, super important. Don't skip that, or you'll have to go back and fix it later, which is annoying. All right, and here's the VS Code download page. Again, big button, can't miss it. Download it, install it. Pretty standard stuff. Okay, there we go. Now, once you've got VS Code installed, you need to grab the Python extension. Let me show you. Searching Python, and yeah, you'll see this extension right here by Microsoft. For me, you can see it says installed because I already have it. But for you, there'll be a green install or button or whatever. Just click that and you're good to go, which is, well, it's all you need to start coding.
All right, enough talking about installation. Let's actually write some code. So I'm going to create a new file here. I'll call it main.py. The .py extension is basically how we tell the computer, hey, this is a Python file. Now, the very first program that everyone writes when they're learning a new language is called Hello World. It's like a rite of passage. And in Python, it's honestly ridiculously simple. So, we're using this function called print. And what print does is, well, it takes whatever you give it and displays it in the terminal. That's the black box at the bottom of your screen. I'm putting hello world inside quotes because, well, that's text, right? That's what we call a string. If you don't put quotes, Python is going to think hello is a variable name or something, and it'll freak out. Okay, so up here in the top right corner, you see this little play button? That's how we run Python files in VS Code. Let me just click that. There we go. Hello world. And just like that, you are officially a programmer. Congratulations. I know it doesn't look like much, but you just told a computer to do something, and it listened. That's the foundation of everything we're going to build today. Now, before we move on, let me change this message to something more fun. So yeah, nice. Okay, so you can put any message you want in there. Seriously, try it out. Get comfortable with this. This is your playground now. All right, so printing stuff is cool and all, but our programs right now are kind of static, right? Like they just do one thing and that's it. We need a way to make our programs remember things. We need them to be dynamic, to adapt. And that's where variables come in. Let me switch back to the slides for a second and show you what I mean.
Okay, so what is a variable? Think of a variable as a labeled storage box. You've got this box, right? And on the outside, there's a label. That's the variable's name. Something like user score or player health or age. That's basically how you identify the box. Inside the box, you've got the actual content, the value. So if your variable is called user score, maybe the value inside is the number 100. And then there's the action. When you write something like user score is 100, you're telling the computer, hey, take this number 100 and put it in the box labeled user score. That's it. That's assignment. Now, here's the cool part about Python specifically. You don't actually have to tell Python what type of data you're putting in the box. In some languages like C or Java, you have to say this box holds integers or this box holds text. But Python, it just figures it out. It's smart like that. All right, let me clear this file and start fresh. We're going to create a few different variables just to see how this works. So yeah. First variable is name. I'm setting it to Codino. Notice I'm using double quotes here, but honestly, single quotes work just fine too. It's mostly just personal preference. I usually stick with double quotes, but you do you. And then, next up is age. This is a whole number, no decimal point, so Python's going to treat this as an integer. We'll talk more about integers in a second. So yeah, and here's price. Notice the decimal? Yeah, that actually makes this a float. That's what we call numbers with decimal points in programming. So, last one is online. I'm setting this to true with a capital T. This is what we call a boolean. It's either true or false. That's it. Two options. And booleans are, well, they're the foundation of how computers make decisions, which we'll get into in part 2 when we do if statements. So, let me just print all of these out so we can see what we've got. Yeah. Okay, there we go. Perfect. You can see in the terminal, Python just remembers all of these values. And now we can use them anywhere in our program.
Now, it's not explicitly mentioned in the slides, but it's super useful. There's this function called type, and what it does is, well, it basically tells you what kind of data is stored in a variable, so that you aren't just guessing. Let me write a bit of code to show you. Wait a second. Yeah, so I'm typing out print, then type, and putting name inside the brackets. So I'm calling print, and inside that I'm calling type and passing in our name variable. Let's see what happens. Let me just run this. There we go. It says class str. That's just Python's way of saying this is a string. The word class is a Python thing we'll learn about way later, but for now, just focus on that str part. That's how it happens. Let me try this with the age variable. Wait a sec. Let me type out print, type, and then age. Let's run that. Yeah, int, short for integer. Makes sense, right? Wait a sec. Let me do one more with price so that we can see the difference. I'm typing out print, type, and then price. And there it is, float. Yep. So, why is this useful? Well, later on, when you start getting errors in your code, and trust me, you will, half the time it's because you're trying to do something with the wrong type of data. I mean, so that if you're trying to add a number to a word, being able to check the type it's a lifesaver. It makes debugging way better. Okay, another thing that's not on the slides but is absolutely important, which are comments. So, when you're writing code, you're going to want to leave notes for yourself, like, why did I write this? Or, what does this section do? And the way you do that in Python is with the hash symbol. See that? Anything after the hash symbol, Python just skips it. It doesn't run it. It doesn't care about it. It's purely for you, the human. So, let's say we want to store the user's information here. Well, you can also put comments at the end of a line of code, like this. I usually like to drop comments here and there just so I don't forget why I wrote something 6 months from now. Future you will thank present you, trust me. All right, moving on. So let's talk about the 4 main flavors of data in Python. We call these primitive data types. Okay, first is string. That's text. Anything in quotes. Hello, Codino, even 1, 2, 3 in quotes is a string, not a number. Then we have integer, which are whole numbers. 25, -10, 0, 1,000, no decimals. Then there's float, which is basically decimal numbers. 9.99, 3.14, -0.5. If there's a decimal point, it's a float. And finally, boolean. True or false. That's it, just 2 values, capital T, capital F. Now, we will cover non-primitive data types like lists and dictionaries in the next part of this course, but for now we're keeping it simple with these 4. Before you go wild creating variables, we need to talk about naming rules, because Python is, well, it's pretty strict about this. First, the character set. Names must start with a letter or an underscore, never a number. So user1 is fine, but one user will throw an error. And you can only use letters, numbers, and underscores. No spaces, no dashes, no special symbols like at or percent or anything like that, which is pretty important to remember. Second, style and readability. In Python, we use something called snake case for multi-word names. So instead of user score or user score, you write user underscore score. All lowercase, words separated by underscores, which is, well, it's the standard for Python. And here's a big one. Never use Python's reserved keywords as your variable names. Words like print, if, while, for. These are special to Python. If you try to name a variable print, yeah, Python's going to be very confused. So yeah, keep your variable names descriptive, use snake case, and don't break the rules. Simple enough. All right, so we know how to store data now, but storing data is kind of useless if we can't do anything with it, right? So let's talk about how to actually manipulate this data. Okay, there we go. Let's see how to make the computer do calculations for us.
So, Python can handle basic math. Addition, subtraction, multiplication, division, basically all the stuff you learned in school. We've got addition with the plus sign, subtraction with the minus, multiplication, which is that little asterisk, and division with the /. But Python also has some, well, let's call them superpowers, which are, First, the exponent, which is just 2 asterisks. This is for raising a number to a power. So 2 * 3 is 2 to the power of 3, which is 8. And then there's the modulo, which is the percent sign. This finds the remainder when you divide two numbers. So 10% 3 is 1, because 10 divided by 3 is 3 with a remainder of 1. These two, exponent and modulo, are super useful once you start doing more advanced stuff. Modulo especially shows up all the time in programming, like, is this number even or odd? Well, if your number modulo 2 is 0, okay, there we go, it's even. Boom! All right, enough theory. Let's actually build something. We're going to create a simple tax calculator. Nothing fancy, just, well, imagine you've got the price of an item, you've got a tax rate, and you want to calculate the total. So, we start with our item price. Let's say it's $100. So yeah, notice no $ here, just the number. And so the tax rate is 5%, which we write as 0.05. Because percentages are just, well, they're just decimals, right? 5 divided by 100. Now here's the math. We're calculating the total by taking the item price and adding the tax. The tax is the item price times the tax rate. Notice I'm using parentheses here. Just like in school math, parentheses control what happens first. So Python's going to do the multiplication first, then add that result to the item price. If I didn't use parentheses, it would still work in this case, but it's just good practice to be explicit, which is safer for your code. And let's just print the total. Perfect. 105.0. That's our item price plus 5% tax. And this, well, this is the logic that powers every checkout screen in the world. Amazon, eBay, your local grocery store, somewhere in the code, there's a calculation exactly like this. Let me show you a few more quick examples with these operators, just to well, see how they behave in the real world. So, straightforward addition here. So, yeah, prints 15. Simple enough. Now for subtraction. Okay, there we go. It prints 5. And multiplication, which is 50. Now, check this out. Division. Notice it's 2.0, not just 2. That's because division in Python always returns a float, even if the result is a whole number, which is a really important distinction to keep in mind. Next up is the exponent. So 10 to the power of 2, 100. Perfect. And finally, modulo. 10 divided by 3 is 3 with a remainder of 1. So, yeah. Yep, prints 1. So, play around with these. Try different numbers. See what happens if you do something weird like 5 divided by 0. Spoiler, it'll crash. But that's how you learn, which is, well, it's all part of the process.
One more thing about math in Python, which is, well, it's the order of operations. You remember PEMDAS from school. Parentheses, exponents, multiplication, division, and then addition and subtraction. Python follows those exact same rules. So, what do you think this prints? Is it 20 or is it 14? Well, let's see what happens. It's 14, because Python does the multiplication first, which is 12, and then it adds the 2. If you wanted it to be 20, well, you'd need parentheses. Okay, there we go, 20. So yeah, parentheses are your friend. When in doubt, just use them. It makes your code so much clearer, and it prevents those weird little bugs from creeping in, which is always a win.
All right, quick detour into 2 more operators that you'll see sometimes. First is floor division, which is 2 forward slashes. This is like regular division, but it basically rounds down to the nearest whole number. Wait a second, let me just write some code to show you. So yeah, See the difference? Regular division gives you 3.33 repeating. Floor division just, well, it chops off the decimal and gives you 3. This is super useful when you need a whole number and you don't want to deal with decimals. Like, I don't know, calculating how many full weeks are in a certain number of days. And then there's also something called the equality operator, which is, well, it's 2 equal signs. This checks if 2 values are the same. Let me write a bit of code for this. So, 5 equals 5 is true. 5 equals 10 is false. Makes sense, right? We'll use this a lot in part 2 when we start doing if statements, but I wanted to show you now so it's not a surprise later on, which is, yeah, always better to see it early. Okay, so we've been playing with numbers a lot, but what about text? What if we want our programs to, I don't know, greet the user by name or display a custom message? That's where strings and fstrings come in. So yeah, okay, there we go. Let me show you how that works.
All right, so strings. We've already used them a bit, but let's go deeper into how they actually work. In the old days, and by old days I mean like 2015. If you wanted to combine text with a variable, you'd have to do something like this. Well, you'd use plus signs to join everything together. You see how messy that is? You've got all these plus signs, and you have to remember to add spaces manually, and if you forget a quote somewhere, yeah, it's a total nightmare, which is why nobody likes doing it that way anymore. But then Python introduced fstrings, and fstrings are, well, they're basically magic. The way it works is you put an F right before the opening quote, and then you can drop variables directly into the string using curly braces. So much cleaner, right? The F tells Python, hey, this is a formatted string. Look for curly braces and replace them with the actual variable values. Wait a sec, let me write a bit of code to show you this in action. Okay, there we go. Okay, so I've got a variable called name, and it's set to Simanta. That's my name, by the way. Wait a sec, let me just write the print for this. Okay, done. Now I'm using an F string here. See that lowercase f right before the quote? And inside the string, I've got curly braces around name. Let's run this and see. Beautiful. Welcome back, Simanta. Now let me show you what happens if you forget that F. Yeah, it prints it literally. It doesn't replace the curly braces with the actual value. So don't forget that little f at the start. It's small, but it's absolutely crucial, which is a mistake everyone makes at least once. Let me give you a few more examples so you really get comfortable with this. Let me write some code here for age and city. Perfect. You can have as many variables as you want in one F string. Just wrap each one in curly braces. And here's something cool. You can actually do calculations inside the curly braces themselves. Let me show you. Wait a sec. See that? It calculated the price times the quantity and dropped the result right into the string. You don't even have to create a separate variable for the total if you don't want to. So yeah, F-strings are incredibly powerful. Once you start using them, you'll never want to go back to the old way, which is, well, it's just much cleaner. All right, so up until now, all of our programs have been kind of boring, right? Like we hard code the values, we run the program, and that's it. There's no interaction. But what if we want the user, someone running our program, to actually provide some information? Like, hey, what's your name? Or how old are you? That's where the input function comes in. Here's how it works. The user types something into the terminal, they hit enter, and whatever they typed gets stored in a variable. But, and this is a big but, the input function always returns a string. Always. Even if the user types the number 25, Python sees it as the text 25, not the actual number 25. This is important, which is something we'll deal with in just a second.
Let me show you how this works. Oh, wait a sec. Let me just write the input line here. So the input function takes a prompt. That's the message the user sees. In this case, enter your age. The user types something, hits enter, and boom, it's stored in the age variable. Let's print it back to them using an F string. Let's run this. Okay, so the program is waiting for me to type something. Let me type 25. Nice, it works. But now, let me show you the problem, which is where things usually go wrong for beginners. So what do you think happens here? I'm trying to add 5 to the age. Seems reasonable, right? Wait a sec. Let me run this and type 25 again. Boom. Error. Type error. Can only concatenate string to string. So what's happening here? Well, remember, the input function always returns a string. So even though I typed 25, Python sees it as the text 25, and you can't add a number to text. It just doesn't make sense to the computer. Now, if I had put quotes around the 5, well, it would work, but it would just stick the two strings together. It'd print 255, which is definitely not what we want. So how do we fix this? Well, okay, there we go. This is where typecasting comes in. Typecasting is just, well, it's converting data from one type to another. See? If we want to turn that string 25 into the actual number 25, we use the int function. We're wrapping the string in int, and Python translates it into a number. And the way we do this with input is we wrap the entire input function inside of it. So yeah, let me show you how that looks in the code.
So now, instead of just the basic input, I've got int around the whole thing. Wait a sec. Let me just finish this line. Python's basically going to execute this from the inside out. First, it gets the user's input as a string. Then, immediately, it converts that string into an integer. And now, well, let's try the math again. I'll type 25, and okay, there we go. It printed 30, because now Python actually sees age as the number 25, and 25 plus 5 is 30. Makes sense, right? So yeah, whenever you're getting numeric input from a user, you almost always want to wrap it in int or float, depending on whether you need whole numbers or decimals, which is, well, it's just one of those things you have to remember. Let me write a quick example for float real quick. So yeah, same idea here. Using float lets you handle those decimal numbers from user input, like 19.99. It just, well, it works exactly the same way.
All right, quick detour. Python has a bunch of built-in functions that are just, well, they're super handy. We've already used print, input, and type, but let me show you a few more that you'll use all the time. First is len, which is for the length of a string. Wait a sec, let me write a quick example here. I'll just type out len, open the brackets, and put hello world inside. Okay, so len counts how many characters are in a string. Hello world has 11 characters, including the space, which is something people often forget to count. It literally counts every single tiny thing inside those quotes. Then we have ABS, which is for absolute value. Let me just type this out. I'm writing ABS, and let's put -10 inside it. So it basically turns negative numbers into positive ones. It's super useful for, I don't know, calculating distances or differences where you don't care about the direction, just the amount. And then there's round for rounding a float. Okay, there we go. Let me type 2 versions of this. The first one rounds 3.7 to the nearest whole number, which is 4. The second one, where I'm putting 3.14159 and then a comma 2, rounds pi to 2 decimal places, giving you 3.14. This is super useful when you're dealing with money or percentages and you don't want a million decimal places cluttering up your screen. It keeps things clean, you know? So yeah, those are just a few. There are tons more built-in functions in Python, but we'll just discover them as we go. You don't need to memorize the whole dictionary today. Okay, real talk for a second. You are going to get errors, like a lot of errors, and that's completely normal. Even professional developers with 10+ years of experience still get errors every single day. The key is just learning how to read them instead of getting scared of the red text. Let me show you the two most common errors you'll run into. First, the syntax error. Let me write a broken line of code here by typing print, then the quote, but I'll stop before the closing bracket. Wait a sec. Notice I forgot the closing parenthesis. Python says syntax error. Parenthesis was never closed. Syntax just means the grammar of the code. Python's basically saying, hey, I was expecting something here, a closing parenthesis, and I didn't find it. It reached the end of the line and was like, wait, where's the rest? The fix? Well, just add the parenthesis. It's usually just a typo. Then there's the type error. We saw this earlier, but it happens when you try to do something with the wrong type of data. Let me write this out again. I'll type age as a string, 25, and then try to add 5 to it. Python's telling you, man, you're trying to add a number to a string. That doesn't work. It's like trying to add apple plus 5. The computer just gets confused. The fix, typecasting. Convert that age to an integer first so the math actually makes sense. So when you get an error, don't panic. Just, read the error message. Python's usually pretty good about telling you exactly what line is broken and what went wrong. And if you can't figure it out, just Google it. Seriously. Copy the error message, paste it into Google, and you'll find 100 threads on Stack Overflow with people who've had the exact same problem. That is, honestly how most of us learn. It's a rite of passage.
All right, we are in the home stretch here. We've learned variables, data types, math, strings, fstrings, user input, typecasting. Whew, that's a lot. And I know it might feel like a bunch of disconnected pieces right now, but here's the thing. Programming is like Legos. You learn all these individual bricks, and then you start putting them together to build something cool. And that's exactly what we're about to do. We're going to build our grand project, which is the personal bio generator. Yay! This is going to pull together everything we've learned today into one cohesive program. So let me switch back to the code and let's build this thing. All right, fresh start. Here's the idea. We're going to ask the user for their name, their birth year, and their favorite color. Then we're going to calculate their age based on the current year, and we're going to print out a nice little summary, like a profile page. Simple, but it uses everything we've learned. Let's start with the inputs. Wait a second, let me just write a comment first. First input is the user's name. This one's a string, so we don't need to cast it or anything. And then, next is birth year. Let me write a code for this. Wait a second. This needs to be an integer because we're going to do math with it. So I'm wrapping the input in int. And third, favorite color. Another string, no casting needed. Now, we need to calculate the user's age. To do that, we need to know what the current year is. I'm hard coding it as 2026 because, well, that's the year we're in. And the age is just the current year minus the birth year. Super simple math. Okay, there we go. Now let's print the results. I'm starting with a little header just to make it look nice. Let's write the output lines. First line, greet the user by name using an F string. Second line, tell them their age, again, F string. And third line, well, let's compliment their favorite color, because why not? Let's make the user feel good. All right, let me run this and see if it works. Okay, there we go. It's asking for my name. Let me type Simanta. Birth year, I'll say 1998. Favorite color, blue. Perfect, it works. Look at what we just built. This program takes user input, stores it in variables, does a calculation, and uses F strings to create formatted output. That's the foundation of pretty much every piece of software out there. Everything builds on top of this.
So, I want you to try this. Run the program, put in your own information, and then, well, change it. Add more questions. Maybe ask for their city or favorite food. The best way to learn is to experiment. So don't just copy me, build on it, break stuff, and see what happens. That's exactly what every pro developer did when they started. And so yeah, if you're worried about missing any code, don't be. I've put every single line from this session into a repository for you. You can find that link right down in the description, so you can just download it and play around. All right, we are officially at the end of part 1, and wow, we covered a lot. From installing Python and VS Code to variables, math, F strings, and user input. We even put it all together in that bio generator. You now have the power to store data and interact with users, which is, well, it's the foundation of everything. But we're just getting started. In part 2, we're going to give your programs a brain using if statements and loops so your code can make decisions and repeat tasks automatically. And so yeah, if you're worried about practicing on the go, we actually just published the Codino app on the Play Store this month. It's brand new and designed to teach you Python in a way that's super smooth right from your phone. It's free to start, so definitely go check that out. Anyway, if this was helpful, please hit subscribe, give the video a like, and share it with someone else starting their journey. And definitely leave a comment below. Let me know how this first part felt for you. I'm Simanta, the founder of Codino. Thank you so much for watching. And so yeah, okay, there we go. I'll see you in part 2.